Hello everyone. Welcome to the experiential learning class of chemistry of Mount International School. In our school, we focus more on hands-on activities and DIY activities, which are always the best source of learning in a child's life. Today, we are going to discuss on one such experiment, that is Tyndall effect. Tyndall effect is a common phenomena which can be seen in daily life. It can be seen even in your bedroom early morning when you just open up the window. It can also be seen as it is shown in the picture under the shabby trees. So let us have a look that what is Tyndall effect and how we can see it in laboratory. Tyndall effect is the phenomena of visibility of path of light when light passes through colloidal solution. For example, through air having the most of the moisture content, colloidal solutions like milk. Students, we have three types of solutions. A normal solution in which the particle size is very less, and a suspension in which the particle size is much bigger, and thirdly we have an intermediate range of solution which is known as colloidal solution. As you can see in this picture only, that when the light passes through true solution, it is not seen. The path of light is not visible. In the suspension, due to the bigger particle size, the light gets scattered and it got spread in whole of the solution, because of which we can't see the path of light. But in the colloidal solution, as the particle size ranges between both of the solutions, thus the path of light can be easily seen. Now, this phenomena is explained by one of the student of our school. So let us have a look on her experiment.
Hi everyone, this is Ludhiana and today we'll be experimenting on three different kinds of mixtures. The first one is a colloidal solution of diluted milk. The second is a true solution of sugar in water. The third one is flour in water, which is a suspension. And here I have an observation table in which I'll mark my observations. So the first one is whether the mixtures are clear. So as we can clearly see, only the true solution is clear. So I'll mark yes for sugar and water and no for the rest ones. Next is, after we sieve them, is there any residue left? So we'll check it. First we'll go with the colloidal solution. And we can see there is no residue left because the colloidal solution has its particle size between 1 nanometer to 1000 nanometers, so that is pretty small. So we'll mark a no. And next one is for a true solution. Therefore, again, there is no residue left. So a no for sugar in water. The third one is flour in water, which is a suspension. Let me just stir it. Now there is a residue left in a suspension, so therefore we'll have it as yes, because a suspension has its particle size between 1000 nanometers and more than that too. So the third experiment is whether the visibility of light's path is there or not. So here I have a laser beam and I will pass that through different beakers. The first one is a suspension. So as I put light in here, there is no visible path, so I'll mark it as a no. The second one is clear water solution. So you can barely see the reflection of light on the glass, so therefore we'll mark it as a no. And the third one is milk. Now, we all know that colloids can scatter light, and we can see the visibility of path of light, so there we go. And yes, we can see how light has gone from this side of the beaker to the other, so therefore we'll mark it as a yes. And we can check how a true solution does not scatter any light, whereas a colloidal solution does. So here I'll pass light. And you can see that you cannot see the light in the true solution, and in colloids it is clearly visible. Thank you.